Good evening, AP Stats. This is Mr. Kim, and in this video, you'll be able to go over the Chapter 3 review materials. I believe for this chapter, it was very long in terms of the lessons, but when it comes down to the review packet, it wasn't that bad. I hope you guys were able to figure out that this is, some of the questions are a little iffy, but most of these questions are very, very easy to do. Now, the first four questions we did go over in class, but just to reiterate, which of the following relationship would you expect to have a negative association? For the negative association, it means that, and one goes up, the other one should be going downwards. So if you read all of these, A is an example of what we call a no association. There will be absolutely no relationship between those two variables listed. Number of chores and weekly allowances. Well, if you do more chores, then obviously your weekly allowance will tend to go up. The number of hours spent studying and the test grade will also have the same effect, hopefully. Most of the time that's spent not engaging on other activities other than studying will generally increase your scores quite significantly. The number of miles driven and the amount of gas remaining in the gas tank. So the more miles you drive, then the amount of gas that will be remaining is going down. So this is the correct answer. The age and IQ tends to not really have a positive relationship. It will really have a positive and as well as maybe a negative relationship depending on the age, and because our cells they deteriorate towards the end of our lives. So therefore, it's not actually one positive, one negative. It's actually both. So it's D for number one. Number two, given all of these info, I want to find out the equation of the least squares regression line. Now, recall that the slope is always this, so that it's a standard deviation of y over standard deviation of x times the correlation coefficient. So what I'm going to do is I'm going to take those values, 0.5 and 1.2, and then I'm just going to multiply that by 0.64 to get the slope, which is here tells me that is 0.266. So that means that I'm really down to these two choices, and then I will get y hat is equal to 0.267 x plus b. You will use your pair of points, which is your x and y, into this equation. So if I were to say 2.7, right, so 2.7 is your y value. And then you have to subtract that by 0.267 times 3.8 when you do your algebra, and you will get C for your y-intercept. So all I did was just plug it in. 2.7 is equal to 0.267 times 3.8, and move this to the other side so that you can actually get the y-intercept value by itself. All right, so let's do number three. We have R is 0.83, and the correlation coefficient has a negative for Elise and positive for Meg. So it seems like R is generally high because it's higher than 0.8. So which means that they will both display a very strong linear association. The 83 points of the data points are closely associated. That is not what R means. It's not the percentages. It's just a measurement without any units. R has no units. So therefore, we cannot really say any percentages there. This is an example of an R squared. This is unclear because you don't know what the data points look like. And definitely it's not E for this one. All right, so number four, we have R squared, and we have the slope, y-intercept, as well as the standard deviation, the residuals. We don't want to be taking a look at any of that stuff. 80% of the variability in y explained by the linear association with x. That is absolutely true. We're looking for something that's false. Since r is equal to 0.898, the linear association between x and y is strong and positive. Now recall that r squared is 0.8, and when you square root both sides, yes, R does become this in the calculator, but when you square root both sides, don't forget that there's going to be a plus and a minus that comes along with it. So you don't know if your R value is going to be positive or negative. Actually, you do, because look at the slope. The slope is less than 0. In other words, it's negative. Therefore, your R value has to be going down. So it is not going to be a positive number here. So, I'm sorry. So that is going to be false. As x increases y 1 unit, then on y decreases an average of 1.6, which is your slope. So C is a perfect example or perfect description of what the slope is. When x is 0, that's talking about the y-intercept, which you can clearly see right there. And putting those two together would be E, so answer here would be B. Which of the following scatter plots could have created the following residual plots? So look at the residuals in the beginning and look at the residuals at the end. They're both giving you a negative residual. And it seems like that there's a pattern for the residuals. Now recall that pattern in residual means that it needs to be transformed. It's nonlinear for your actual graph. So you want to have a nonlinear graph, which I can see that it's not going to be A or D because they show me a linear relationship. Now, if you were to draw a best line of fit for all of these ones, okay, and generally I think that's how it's going to look like. Look at the residuals from the beginning at the end. I'm going to use a different color to annotate this here. Now notice in the very beginning, for this one, the dots, the actual is below the line. And then when you take a look at this, the dots are above the line. And here, the dot is actually above that line. In the beginning, because the dot is below the line, for the residuals, it means that the actual has to be below the line. So the only one that actually follows that relationship is going to be B. And therefore, it's going to be B for the answers. The other ones, they will tend to look more like this. So if this was the residual, then it would be positive here. Then it will go down because you can see how all the residuals are downwards, and then it will back up. And then for this one, it's pretty much the same relationship. So your residuals, and then it will look like this. Not the upside down parabola. The only one that gives you that is B. Okay, so number 6, which of the following is correct interpretation of the slope? All right, so the first things first, we have to put this on the calculator before we can do anything. To get the equation of the best line of fit, we have to go to what we call a list. So stat, edit, and then I'm just going to type these away. 0, 5, 6, 7, 8, 9, 10, 11, 12, and then you go here. 7.5, 49.8, 58.2, 65.9, 76, 76.8, 88.2, 98, 108.2, 116.9, and that will be all. So if I want to actually calculate this, you go to stat, and then you go to calc, and you go to number 4, which is linear regression modeling. So list 1, list 2, we do frequency list, nothing. Vars y-vars function 1, that would store our equation into y1, and then we'll press calculate. And then you can see that we have the slope and the y-intercept, which is 9.247, and then the y-intercept, which is 4.521. Now with those two info, they want us to correctly interpret the slope, which means that the slope here is this, which is about 9,250 or so, because it's in thousands of students, which means I think the only number that really gives me that is that B and C, the rest of them is going to be garbage answers this time. So for each year, 9,250 more students, or an average of 9,250 more students. I mean, that is really the main difference between B and C. C is not the correct answer because what C is saying, it is a guarantee that every year increase, every year, 9,250 more students, period. But what if you read B, for each consecutive year, an average, replace the word with about. Because an average of 9,250 means that it doesn't necessarily have to be exactly 9,250, but on average, it's going to be that much amount. And that's what I'm looking for. We want those cushioning words. An average of 9,250 more students will be taking the exam. That's the better answer out of the two. And it is the correct answer. C is saying that it's a guarantee it's 9,250, but that's never a guarantee. You never know what's going to happen. So it's going to be B. Number 7, which of the following is the correct interpretation of the intercept? So intercept is this, which makes it 4,500 students, and it's going to be the predicted line. Because remember, it's the best line of fit for y hat, so it's C. Which of the following is the correct interpretation of the coefficient of determination, which is your r squared? Now, to get the r squared, we need to know what r is and square it at the end. Now, recall what we had on the calculator. We actually didn't get anything. Stat calc number 4, and then when we did this, we didn't get the r value. Now, when you run across that problem, all you're going to do is just simply go to mode, and then go all the way down to stat diagnostics, which is the third one or the fourth one from the bottom. Turn it on. And then now let's do that all over again. Number 4, and then I'm just going to press calculate. And now there is my r squared and the correlation coefficient along with it. It seems to me that it's 0.996. I'm just going to write that down. So looking at this, we are looking at a 99.6%. So we're going to eliminate all the ones that says 99.8. And if you read it correctly, the 99.6% of the variability of the number of students in the y variable can be explained by the linear relationship with the x variable. The y has to come first because we're predicting the y, not predicting the x. So the answer is B for this one. Number 9, a set of data has the following residual plot. Which of the following is true? Now, for this, I know a lot of you guys might have struggled. I struggled with this question particularly the most. And the way that I'm going to go over this is it's going to be quite simple. First of all, we should all agree that it's going to be 1 because we see clear pattern for this. That means that it's not going to be a good fit for a line. A linear model is not appropriate. That is absolutely true. So we're going to eliminate B and C just because it's missing the Roman numeral 1 in there. When you go to the next problem, it just says the data shows an exponential trend. If you go to your notes, there are 3 ways in which you can represent a plot. It's either a linear form, it's either going to be a exponential form, and it's other one's going to be what we call a power form. An exponential form is an x versus logarithm of y, and power form is log x versus log y. Now, what is really the main difference between these two is that, first of all, obviously your data has been changed so that your exponents for x and y is compared, or x and your exponents for y can be compared. That's the obvious change. They do look very similar. They do happen to have these little curved patterns. Obviously, the scale will be a lot different, but then they both tend to have the same pattern. The only way that I'm going to explain to you guys why 2 is not going to be true is because you don't know if it's going to be exponential or if it's going to be a power trend. Okay? And besides, believe it or not, I'm sorry, the linear plot cannot work because of the pattern. We just established that. So no, I wasn't gonna, let's not use that one. But the main idea here is that it's either going to be exponential or it's going to be power, and you can never really distinguish between the two unless we have a little bit more info as to what the regular scatter plot looks like. So 2 is just too far-fetched, and we're going to eliminate E because of that reason. The LSRL has a negative slope, and you can see how this one, we really are not given the residual plot's value. Like, is this like 0.1? Is this like 1.0? Is this 0.5? What I mean by that is like the top of the y scale. Like, how different is it? Because depending on how different it is, I can literally draw a positive line. And if that residual, yes, it's the largest one in the graph, but if the residual is so tiny that you really can't tell the difference between all of these, who's also even closer to the line, so it's going to look more like this, something like that, then this one clearly shows a highest residual for this one, but it is so small because all like the scatter plot scale is like in tens, right? And then this one is like 0.1 for the residual scale. So because we don't know the y scale for this, I can see that it could still have a positive relationship. Like, that is the best way that I can explain this to you. Just because you see this downward trend doesn't mean that it's going to be a negative slope. We need to see the numbers on the left-hand side and to see how big it is. If this was indeed like 10.0, that means this is really, really big, right? That's a really huge data point, which means the dot has to be above the line. And then, I won't know how, I wouldn't really know how to graph that because it really depends on how the data looks like, but it's never a guarantee because we really don't know how far this up goes. So number 3 is just also way too far-fetched as well, and so it's going to be A for this one. Number 10, the one that has the farthest away from 0 means that R is close to being -1 or +1. looks to me that all of these have positive trend except for C. And the one that has the closest value to, let's say, 1 is the stronger set of the scatter plots. And so that means that the dot has to be close to the line as much as possible. So we can all tell that it's going to be D for this one. Number 11, which of these five predictors should the realtor use? So we are trying to make the R value as big as possible. 10 and 11 kind of goes hand in hand together, whereas 10 says pick the one that's farthest away from R. You're also going to be doing the same thing for 11 because the one that's farthest away from R is the one that you would like to use to measure and that has the strongest correlation, strongest relationship. So it's A. Regardless of it's negative or positive or not, remember, it can be close to 1 or negative 1, and they will both have strong relationship. It means that the direction is just going to be different. So yes, it's going to be A for this one. And just take the absolute value next time if that ever confuses you. The R value must be absolute value to measure the strength. And that's probably like a small tip that I'll tell you for number 11. All right, for number 12, we have R squared equals 0.25. I mean, if they specifically said that and said comma, which of the following is a correct statement? They probably want you to say something in regards to that. Now, recall, R squared has the template, which is the percent of that variable, percent of that number. That's how much a variation can be explained by the LSRL. So it's going to be E. Don't even bother looking at the other ones. That's the one you want to go for. Okay, so we want to find out the smallest to largest correlation coefficient, which means R. Once again, this is kind of like 10 and 11. Draw a line. Okay, which one is closest and which one's the farthest? So it seems to me this one will yield the smallest R because it's the weakest, and this one yield the biggest, largest R because it shows very strong relationship. So we're going really 1, 2, and 3 in that order, from weakest to smallest. So it's going to be A for this one. All right, so number 14, all of the scatter plots. All right, so all the scatter plots are drawn to the same scale. Which one has the standard deviation of the least squares regression line residuals the smallest? So once again, if I draw the line, and actually for E, I should probably draw it like this. If I really want to have a smallest S value, that means, again, I want to make the R value to be the strongest as possible. Why? Because the smaller the residuals are, if the gap between the line and the dots are small, it means that the residuals do not vary that much. A residual varying from R negative 0.5 to positive 0.5, right? Or I'm sorry, I shouldn't say that. I should say the residuals. I don't mean the correlation coefficient. If all the residuals in the graph, in other words, if I were to just calculate all of these small differences between actual and predicted, and if they're somewhere between those two, you can see how they vary from negative 0.5 to 0.5. Their variability is about 1, like the range is about 1. But if I were to find out another one that has a residual that's ranging from this, which means it shows a higher residuals, it shows much more differences between the actual and the predicted. It shows much less correlation. This means that it has higher standard deviation because there's just much more variability. In other words, there's an inverse relationship between S and R. As the line is a better fit for the scatter plot, your standard deviation of the residuals will go down. So the strongest one here again is B. That's all you have to do. All right, so for number 15, now this kind of tricked me because it looked like a computer output. But if you take a look at the actual computer output that we did beforehand, I guess we haven't done one. So it looks like this. There's got to be the word predictor and coefficient. But this is actually not that. They just gave you the standard deviation S of X, S of Y. And this is just the mean of Y, or mean of Y, and then the mean of X right here. And so I guess this is what you really have to use to figure out the slope, but they actually were nice enough to give that to me. They want you to find the residuals, which means it's actual minus predicted. So we want to find out the predicted by using this line when the gasoline lead value is 82. So you're going to go to your calculator here. And what you're going to do is, let's press clear. I'm going to plug in 82 into G. And then so I'm going to do 82 times 0.014, 82 times 0.01489, and then plus 4.108. And so, seems to me we have 5.32898 for your U hat. So the umbilical lead, whatever that is. Okay, so U value is 5.32898, and you're going to take that value, and then you're going to, that's the predicted, and you're going to subtract that from the actual, which is provided for us as 4.5. So 4.5 minus 5.32898 roughly yields me about 0.8ish or so. Oh, negative. My apologies. A negative 0.8 means it's going to be A for that one. All right, number 16, we have which of the following is not true of R? So R is not going to have any units whatsoever, no units. So it's independent of whatever the units of Y and X is. Yes, that's absolutely true. R is always between 0 and 1. No, it's always between negative 1 and 1. So that is not true. R measures the strength between the X and Y. Yes, that's true. R does not depend on the two variables labeled as X. What that means is if I were to swap the Y and X and label the horizontal as Y and the vertical as X, they won't matter because all the dots and the line, the residuals are squared. So the height of the square is the same as the width of the square going that way anyways. So either way, you're gonna see the same exact residuals for those. And then your equation is gonna be pretty much the same. So that's not gonna matter. R is less than 1.0 unless the points on the scatter plot line up exactly. Yes. A perfect R would mean that all the dots falls in that one singular line and you hit through every single one of them. So that's not true. So it's going to be B. All right, so 17 and 18, the estimate for the population, the regression line, I'm not really going to help you with that. You should already know. That's the slope. That's the y-intercept. So you pick that one, which is D. The estimated standard deviation, hello, right there. That's a no-brainer. All right, so next one. What is the value of the correlation coefficient for these data? Now, I know that you guys can say that R squared is 0.369. And when you square root that, I believe you do get 0.607. And then you guys would have picked E. But please take a look at the slope. Please be careful because it's a plus and a minus when you decide to square root those two sides. So is it going to be positive or negative? Well, look at the slope. The slope is going downwards, as you can see. It's a negative 0.6382. So if it's going down, your relationship also has to be going down. So your R value also has to be negative, which makes this to be B. Number 20, what proportion of variability in salary? Now that sounds awful familiar, a lot like R squared to me. So I'm just going to put R squared, which is the proportion of 0.369 here. Okay, so 21, we have the residuals with the log of X. Clearly see a pattern, and as you can see, this is what I meant. That's the example of a power function, whereas both log of X and log of Y is presented. The X and Y, they're both taking logarithms of. And if you take a look at this, this is called exponential because you have regular X and you have a log of Y. Only Y has been taken logarithm of. Which the following equation is correct? So it seems like model B is appropriate because we see randomness, and randomness is always good. So model B is appropriate since the relationship between X and log of Y is linear. We want to say that it's log of Y specifically because you have to follow the equation. X and Y originally probably wasn't, and you have absolutely no info of the X and Y graph for the residual, so we really can't tell what that is. All right, number 22. We're doing the same thing. Second regression, this one is power. And this one, it's the actual, basically the regular scatter plot, because there's no logarithms taken care of anywhere. But what is that? So then how would that yield the result? This is a pattern. So there is not a linear relationship between x and y. So there's a nonlinear relationship. That's what you want to go for. And seems to me that regression 2 is a better fit. So it's E, because there's absolutely no pattern. I mean, if you call this a pattern like this is not a pattern. This seems like it's very scattered throughout. It's obviously better than this, of course. Okay, so I'm gonna stop here. I'm going to post the free response of the review on the separate video. And so I'll see you on part 2 of chapter 3 AP review.